So in this lecture, I'm first going to give an introduction to the parsing problem. We'll then describe context-free grammars. I'll then give a very brief sketch of how we can apply context-free grammars to develop a model of the grammatical structures seen in English. And finally, I'll focus on ambiguity and describe some examples of ambiguous structures. Ambiguity is an extremely prevalent problem, as we've seen, in general in language processing, and it's certainly a very prevalent problem in natural language parsing. So here, in a nutshell, is a definition of the parsing problem. So as input, we take a sentence. For example, Boeing is located in Seattle. And as output, we're going to produce an object called a parse tree. And so the parse tree is a tree structure with the words in the sentence at the leaves of the tree. So Boeing is located in Seattle. We see the leaves here. And we see the tree has labels on these internal nodes such as NP, PP, VP, S, and so on. And very soon we'll describe exactly the role that these different labels play. But at a very high level, we now have some kind of hierarchical decomposition of the sentence into this associated tree structure. So the parsing problem has its roots in theoretical linguistics, and it really goes back to the start of modern linguistics, largely due to Chomsky in the 1950s. And one book I highly recommend if you want to learn more about the roots of modern linguistics is a book by Chomsky, I believe from 1957, called Syntactic Structures, which is a hugely influential book. It's really a beautiful book. And since then, there has been an enormous amount of research in linguistics on the syntactic structures of different languages, looking at a wide range of formalisms. I've listed a few here. For example, lexical, functional grammar, LFG, head-driven phrase structure grammar, tree-adjoining grammars, categorical grammars. And the formalism we're going to concentrate on today is the formalism of context-free grammars, which are really fundamental and, in some sense, form the basis for all of these modern formalisms. So as it turns out, we're again going to treat the parsing problem as a supervised machine learning problem. And so we're going to assume that we have training data consisting of sentences paired with their underlying parse tree. So here I actually have a parse tree. So this is one example actually taken from a resource called the Penn Wall Street Journal Tree Bank. And I don't expect you to read every word of this. We have a sentence of around 30 words in length, and we actually have a full syntactic structure for that sentence. So where do these syntactic structures come from in this training data? They've actually been annotated by hand. So the Penn Wall Street Journal Tree Bank was one very early example of a resource. We call it a tree bank. Tree bank is a collection of training data consisting of sentences paired with parse trees. And the Penn Tree Bank had around 50,000 sentences. This is, I think, roughly 1 million words of data. And this has been annotated by hand. So humans have actually gone through sentence by sentence. They have an understanding of the underlying linguistic theory, and they have annotated these full parse structures for each of these sentences. Now that clearly is a very laborious task, but the net result is that we do have a large amount of training data from which we can train a supervised learning model. So a usual setup, for example, is to take some portion of the entire data set as a training sample, maybe 40,000 sentences might be typical, and to take some portion as a test sample, and to somehow train a model that aims to take sentences as input and produce parse structures as output. We train that on the training examples, and we can test the performance of the model on these test examples so we can get an accurate measure of how well the model's actually performing. So let's now give a sketch of the information that is represented by these parse tree structures. Again, focusing on a very simple example, the sentence, the burglar robbed the apartment. And we'll go through a number of levels of representation in these structures. Okay, so at the very first level, if we look at the level above each word in the tree, we see that we basically have the part of speech for each word. And so we have DT here for determiner, N here above burglar for noun, V above robbed for V, and so on and so on. So this very first level of the tree simply encodes the part of speech tag sequence for the input sentence in exactly the same way as we saw with the part of speech tag sequences in the previous section of this course on part of speech tagging. So that's the first level. If we look a little higher, we're going to start to see some hierarchical grouping of words into phrases, or what are often called constituents. So if I take any node in this tree, take for example NP, this NP node here, it indirectly dominates a sequence of words. So this dominates the two words there and burglar in this case. And that means that this particular substring, the burglar, has been identified as a constituent or phrase of type NP. NP actually stands for noun phrase. Later in this class, we'll talk extensively about what these different categories are. But as you can see, the main point here is that we get this hierarchical grouping. This NP here, we have a second NP. Again, this indirectly dominates a substring in the sentence, in this case, the followed by apartment. And so we identify the apartment as another NP. If we go a little higher in the tree, this VP dominates the substring robbed the apartment, and so we know that this substring is of type VP. That stands for something called a verb phrase. And then finally, at the top level of the tree, we have S, which stands for sentence, and that S node indirectly dominates the entire subsequence, so that dominates the burglar robbed the apartment, so we know that this substring is an S. So finally, and in some sense most importantly, these parse trees encode very important grammatical relationships within a sentence. So let me again come back to this example to illustrate this. So let's look at this little tree fragment I have up here. So this is, in some sense, a template. Whenever I see a structure like this, so I have some word here with a V above it, with a VP above that, and then with an S here, and then an NP off to the left, I can simply read off the fact that I have a subject under this node here, and I have the verb here, and these two things stand in a subject-verb relationship. So let's apply this to this tree. We can apply this template and see that robbed is a verb, and moreover, the burglar is the subject of that verb. So these trees make this particular relationship, subject-verb, completely transparent. If I can recover this parse tree, I can simply read off, or I can identify fragments of the tree where I see this template and read off relationships such as subject-verb. Let me give you a second important relationship. So whenever I see a substructure of the following form, so I have some word here, and I see an NP to the right under here. So this is actually going to be a direct object, and this, sorry, is going to be the verb. And so whenever I see this configuration, I can read off a relationship between a verb and its direct object. So if I apply this to this particular example, I can see that the apartment is the direct object of this particular verb. And there are many other templates corresponding to many other grammatical relationships seen in English or the language that we're looking at. So in short, these syntactic structures allow us to read off different grammatical relationships, and that's crucial because it allows us to identify who did what to whom. If I want to identify who did the robbing, I need to find the subject. If I want to identify what was robbed, I need to find the direct object. Now, in this example, and many other examples in this lecture, I'm going to use really rather simple short sentences. And so this might almost look like a trivial problem to you. But what I want to emphasize is that when you get to longer sentences, say 15, 20, 30, 40 words in length, it is a very difficult job to recover these grammatical relationships. So these past structures are invaluable in revealing grammatical relationships such as subject-verb or verb-direct-object.